Sir James Martin, a self-taught engineer and inventive genius, was over 50 years old when he began the work that gained him international recognition as one of the great British engineers of the 20th century. James Martin, shown here at age 14 with his sister and mother, was born in the Ulster province of County Down, Northern Ireland, on September 11, 1893. Martin became fascinated with airplanes at an early age, and by 1929 he was able to start his own company. In 1934, he partnered with Valentine Baker, a flight instructor and former World War I pilot, and reorganized as the Martin Baker Aircraft Company. From the 1930s to the end of World War II, the company developed and built several promising aircraft designs. None was put into production, but Martin's creativity benefited the war effort in many other ways, including innovations which increased the effectiveness of aircraft weapons, a system that enabled Spitfire pilots to jettison a jammed canopy, and a cable-cutting device to keep low-flying British bombers from being downed by their own barrage balloon cables. However, James Martin's most significant achievements would come in the field of aircraft escape systems. At relatively low speeds, bailing out of an aircraft was reasonably straightforward and safe. Above 200 miles per hour, as shown in these high-speed blower tests, the force of the slipstream made it difficult to exit the cockpit and increased the probability of the pilot striking the tail section. As jet fighters were being developed during World War II, Great Britain's Air Ministry approached Martin Baker to develop a method of safe egress at higher aircraft speeds. Using his natural talent for innovation, Martin invented the basic components of the modern ejection seat, making rapid escape from a stricken aircraft both effective and safe. He engineered important features such as the quick disconnect fittings for a pilot's radio and oxygen systems, and a face blind or cover that restrained the pilot's head, protected his face from the wind blast, and fired the ejection gun that projected the seat upward.
With this equipment, the pilot is fired out of his disabled aircraft like a shot out of a gun. The seat is a complete unit.
In this Royal Air Force training film, British actor Desmond Llewellyn explains how the seat works.
This long tube inside here is the ejection gun. It's fired like any normal gun. It's loaded with 2 cartridges.
At the Martin Baker plant, the first tests of the new ejection seat system were accomplished in January of 1945 on a test rail that Martin designed. The next step was a series of dummy ejections from the rear cockpit of a specially modified Meteor jet. On July 24, 1946, Bernard Lynch, a fitter in Martin Baker's experimental department, accomplished the first live ejection from an aircraft. Benny Lynch was known for his love of beer, and he landed from this noteworthy test within walking distance of a local pub, where he celebrated his success. The Martin Baker ejection seat was fully adopted by the Royal Air Force in 1947, and pilots were trained in an entirely new approach to bailing out of an airplane.
Feet and head on rest. Hold your breath, keep your mouth shut. Elbows in, pull down the blind and out you go.
Over the years, Martin's flair for imaginative thinking and bold experimentation resulted in continual improvements to the capabilities of his company's ejection seat. By 1955, he had developed a seat that could safely eject a pilot at runway level on takeoff or landing. Martin's next innovation was to add a rocket assist to the regular ejection gun, making it possible for a pilot to eject at ground level with 0 airspeed. The first live 0-0 ejection was made by W.T. Hay on April 1, 1961. The rocket seat considerably increased the odds of a successful ejection, even from aircraft with a nose-down attitude or a high sink rate, a development greatly appreciated by George Aird when he ejected from his English Electric Lightning fighter in 1962. The Martin Baker ejection seat eventually became the standard for emergency escape systems all over the world. James Martin's success in this critical field of aerospace technology was due to his thorough engineering, attention to detail, and high standards of quality control. Martin received many honors for his work. By 1965, 1,000 lives had been saved by Martin Baker ejection seats, and James Martin was invested as a night bachelor. To date, over 7,000 lives have been saved by Martin Baker ejection systems. for his outstanding aerospace engineering in a multitude of applications, and particularly for advancing the science of emergency escape systems from high-speed aircraft. We honor him now and invest Sir James Martin with membership in the International Aerospace Hall of Fame of the San Diego Aerospace Museum. March 13, 2004. Were captivated by the excitement of flight, and by 1912, both were working with famed exhibition pilot Lincoln Beechey, Grover as a pilot and Larry as a mechanic. The following year, Larry went to work for aircraft manufacturer Glenn L. Martin, where he eventually became Martin's general manager. In 1928, he was hired by Reuben Fleet at Consolidated Aircraft in Buffalo, New York, where he again quickly rose to the position of general manager. In 1935, when Fleet decided to move Consolidated Aircraft to San Diego, Larry stayed in Buffalo to form his own company. The Bell Aircraft Corporation was founded on July 10, 1935. The first aircraft produced by the new company was a twin-engine interceptor called the Aerocuda. Although it was not put into production, this unusual design featured several innovations such as the first aircraft auxiliary power unit and the first remote fire control system. In 1937, Bell Aircraft won a bid for a modern fighter aircraft design, and the first Bell P-39 Aerocobra flew on April 6, 1938. The P-39 was the first American single-seat fighter to incorporate retractable tricycle landing gear, and it was the first to feature a cannon firing through a hollow propeller shaft. The Aerocobra established Bell Aircraft as a major player in the aviation industry, with a production run of almost 10,000 aircraft. Even before America's entry into World War II, Bell Aircraft was chosen to develop, under the veil of secrecy, the United States' first jet-powered aircraft, the P-59. Powered by two British-designed jet engines, the P-59 first flew on September 30, 1942. Over 60 P-59s were built, and this pioneering design was invaluable for familiarizing pilots with the performance and handling characteristics of jet aircraft. While working on the P-59, Bell Aircraft also flew its first helicopter in 1942. Over the next 4 years, Bell developed the design into the Model 47, which was the first helicopter ever to be certified for commercial use. In 1950, the Korean War broke out, and Larry Bell found himself with an Army contract of 500 of these versatile helicopters. Highly effective in the swift evacuation of battlefield casualties, the Model 47 was credited with saving thousands of wounded soldiers' lives due to their speedy transport to Mobile Army Surgical Hospital, or MASH units. While his Model 47 was a technological and financial success, Larry Bell's most famous aircraft had already taken aviation technology into a new dimension, beyond the sound barrier, and had earned him the prestigious Collier Trophy. As World War II was drawing to a close, Bell was awarded an Army contract for a new type of research aircraft, which would be known as the X-1. Powered by a 4-chamber rocket engine, the X-1 would be carried to altitude by a B-29 bomber and air-launched. After a series of glide tests and partial power flights by Bell's test pilots in 1946 and early 47, the project was turned over to the Air Force, and a young captain named Charles Yeager was assigned as primary test pilot. Yeager gained experience on the X-1, gradually creeping toward Mach 1, the speed of sound. On October 14, 1947, he flew the X-1 through the sound barrier, and people on the ground heard the double crack of a sonic boom for the first time. Larry Bell and his company had built an aircraft that ushered in a whole new era of high-speed flight research. For an outstanding aerospace career in which he introduced numerous innovations in aviation technology, and particularly for his significant and lasting contributions to the development of both rotary and fixed-wing aircraft, we honor him now and invest Lawrence D. Bell with membership in the International Aerospace Hall of Fame of the San Diego Aerospace Museum, March 13, 2004. Stanley Hiller Jr. was born in San Francisco, California on November 15, 1924. As a teenager, he was fascinated by aviation, especially by accounts of Igor Sikorsky's development of the helicopter. He had never seen a helicopter fly, but in 1942, he sold the model race car business he had started 2 years earlier and founded Hiller Aircraft. By the age of 18, he was already building his first helicopter, which he called the XH-44, with twin coaxial counter-rotating blades to eliminate the need for a conventional tail boom and rotor. One non-engineering problem Hiller had to address was a lack of experienced helicopter test pilots on the West Coast.
We had no one to talk to about how you would fly a helicopter. We had no one to guide us in methods of determining what loads were on rotors or how rotors would react.
The first test of the XH-44 was a tethered engine run inside a large garage.
We were testing the aircraft fastened to a heavy structure, and I pulled on the pitch only slightly, which immediately took 14 skylights out of the upper part of the roof.
After some false starts and mishaps on tethered test flights, the first free flight of the XH-44 came on July 4, 1944, at Memorial Stadium at the University of California, Berkeley, with the young company president as the test pilot. This was the first coaxial rotor configuration to fly outside Europe, the first helicopter with rigid rotors, the first with all metal rotor blades, and the first helicopter in the western United States. Hiller's helicopters would be known for their outstanding stability thanks to a unique cycle control system he called Rotormatic. The Hiller Model 360 was first flown in November of 1947, and this three-seat helicopter had the longest production run of any piston engine helicopter, almost 4 decades. The Model 360 would also become the first helicopter to fly across the United States. The final leg of the trip was flown by Hiller himself, shown here touching down at the foot of New York's Wall Street. In 1949, 2 Model 360s used by the French government in their war on Indochina became the first helicopters to fly routine evacuations of wounded soldiers in combat conditions. With the outbreak of the Korean War in 1950, a military version of the 360, the H-23, was purchased by the Army and used for medical evacuation as well as other missions. Throughout the 1950s, Hiller developed numerous innovations in the field of rotor wing flight, such as the no-tail rotor concept, which stabilized a single rotor helicopter by replacing the tail rotor with a directed stream of air. The Hornet, a small helicopter which eliminated main rotor torque due to blades being turned by small jet engines at the rotor tips. The Rotor Cycle, a collapsible one-man helicopter that could be parachuted to a down pilot, assembled without tools in 5 minutes, and flown to safety. It was specially designed to be forgiving and easy to fly. And the Flying Platform, able to be flown by leaning in a desired direction of flight, and stable enough to be used as a rifleman's platform. In the late 1950s, a concept first proposed by Hiller in 1947 would evolve into the world's first transport-sized vertical takeoff and landing aircraft. The successful flights of the X-18 in 1959 resulted in a tri-service military contract for the XC-142 to be built by a three-company consortium of Hiller, Vought, and Ryan. Although only 5 were built, the XC-142 remains to date the largest vertical takeoff and landing aircraft ever flown. While pioneering all these innovative concepts, Hiller continued improving on his production helicopter designs. Further development of the original Model 360 and the Army H-23 evolved into the highly successful Model 12. Remarkably versatile with a considerable lifting capacity, more examples of the Model 12 would be sold than all other civil helicopter models combined. Stanley Hiller Jr. ushered in a remarkable number of aviation technologies and innovations through the successful company he founded while still in his teens. Today, he fosters the preservation of aviation knowledge at the Hiller Aviation Institute through its museum and education center. For his leadership in helicopter development with a wide variety of applications to the benefit of mankind, and for his many aeronautical innovations in the advancement of aviation technology, we honor him now and invest Stanley Hiller Jr. with membership in the International Aerospace Hall of Fame of the San Diego Aerospace Museum, March 13, 2004.